Welcome back to the deep dive. We are really in the home stretch of our series now.
We are. We've built the foundation, the workforce, the infrastructure.
And last week, the economics, the return on intelligence framework. We've built a lot.
We have capacity, we have speed, and we have a way to measure the value of it all. But what we don't have until today is control.
And that's the big one, isn't it?
It's the crucial non-negotiable step. So our mission for this deep dive is Chapter 9, Governance 2.0. Because the truth is, all that capacity, all that speed, if it's not governed, it's not an asset. It's a massive liability.
Right. And we have to start with the reality on the ground, the messy reality right now.
Today.
As you're listening to this, someone in your organization is probably using ChatGPT or, some other public LLM to draft a customer email.
And someone else is feeding your proprietary code into a free coding assistant to help them debug.
And maybe a third person is summarizing confidential meeting notes with some tool they found online.
And you didn't authorize any of it. You have no idea what tools they're using, where that data is going, or if the output they're getting is even accurate.
This is what the source material calls shadow AI.
Exactly.
Okay, let's unpack that term, because my knee-jerk reaction, and I think for a lot of people who were around in the 2010s, is to think of shadow IT. Employees using Dropbox, their personal Gmail.
And that contrast is absolutely essential because it shows why this is a whole different ballgame. The risk is just exponentially greater.
How so? Shadow IT felt like a big deal at the time.
It was. But shadow IT was fundamentally a data location problem. It was about files being moved around. The risks were, security gaps, version control nightmares, basically data ending up in the wrong place.
So it was about where the data was.
Right. It was about storage. Shadow AI, on the other hand, is about what the data does. And even more critically, what the AI creates.
So it's not just moving files?
No. It's shaping conclusions. It's drafting communications that could be legally binding. It's writing proprietary code. It's influencing major business decisions.
Wow. So the risk isn't just a data leak.
The risk is that an employee, trying to be more efficient, uses a free tool that just hallucinates a feature in a sales proposal. And now you're on the hook for it. You have a contractual liability based on an AI's mistake that you can't even trace.
It multiplies judgment, for better or worse. And the speed of this, it's terrifying. I mean, shadow IT, you had to install something, get it provisioned.
Now it's just a browser tab. That's it. The barrier to entry for organizational influence is basically dropped to zero.
The analogy in the book is pretty stark. It says shadow AI is like building rooms in your house that you don't know about, and those rooms affect the load-bearing structure.
It's perfect, isn't it? You're losing structural integrity with every single unauthorized prompt.
So we can't ignore it. The tools are just too valuable. But we can't just ban it because, like we said, that just drives it underground.
Which brings us right to the core principle for control. The trust paradox.
Okay, what is the trust paradox?
The central idea is that your governance has to come from a place of trust, not fear. The principle is simple. Shadow AI hides best in fear. It surfaces fastest in trust.
Right. Let's break that down. If my first reaction is just panic, no one is allowed to use these tools, period, what happens?
You get zero visibility. That's what happens. Your employees are rational. They see the efficiency gains. They want to do their jobs better, and if you prohibit the tool that helps them, they're just going to use it anyway.
And they'll hide it.
They'll make sure it's untraceable. And now you can't manage the risk, you can't audit the output, you don't even know what threats you're facing. Prohibition is totally self-defeating.
So trust-based governance is about channeling that energy. It's about giving people a sanctioned path to yes, instead of just a blanket no.
Precisely. You create approved pathways with clear guidelines. And when that sanctioned path is easy to use, people will register their activity. They'll come out of the shadows because it's simpler to comply than it is to hide.
So governance becomes less of a speed limit and more about, designing the car in the road so you can go fast safely?
That's the perfect metaphor. It's about providing guardrails that enable safe autonomy.
Okay, but let's talk about the practical side of that. If I make a policy where an employee has to fill out a 3-page form and wait 3 weeks for IT to approve it.
They're going to keep using shadow AI. Absolutely.
Right, so how do you make it frictionless?
You've hit on the key metric. The book is really clear on this. If registration takes 3 weeks, people use shadow AI. If it takes 3 hours, they register.
3 hours? That's a high bar.
It is. But trust requires speed. It means your framework has to predefine roles, risk tiers, approved environments, so that permission can be automated. Governance has to become an enablement function, not a blocking function.
That's a huge mindset shift. But okay, before we build those guardrails, we have to know what we're guarding against. And traditional security, your standard firewall, just isn't going to cut it.
Completely inadequate. As the source says, a firewall doesn't stop someone from talking your AI into doing something stupid.
So we need AI-specific responses for what the book calls the 5 AI-specific threats. What's number 1?
Let's start with the one that gets the most press. Prompt injection.
Okay, this sounds like something out of a spy movie. What's the actual mechanism here?
It's basically social engineering for software. Every AI has a set of core hidden system instructions. A prompt injection attack is when someone crafts an input that tricks the AI into ignoring your instructions and following the attacker's instructions instead.
It hijacks the control layer.
It completely overrides it.
Yeah.
The example of the inventory system that gets tricked into underordering your most profitable products is a perfect illustration. The AI is still doing its job technically, but it's following the wrong orders.
Wow. Okay, what's the second threat?
Data leakage. Specifically through something called vector embeddings in RG systems. That's retrieval augmented generation.
Okay, can you break down RG and vector embeddings for us quickly?
Sure. RG is what lets an AI search your private documents. It takes that information and converts it into dense mathematical representations, these vector embeddings.
They look like just a string of numbers to us.
To a human, yes. But to another machine, those embeddings encode sensitive information. They're machine readable. So an attacker who gets access to them, or who can manipulate the query, can basically reconstruct sensitive data you thought was safe behind your firewall.
That's a completely different kind of threat from, say, a traditional database attack. All right, number 3, model poisoning.
This is a supply chain attack. The attacker corrupts the model before you even get it by injecting bad data into the training set.
So the model is compromised from day 1.
Exactly. And it's designed to only misbehave under very specific, hard-to-detect conditions. So it might pass all your initial tests.
And then fail catastrophically during one critical operation months later.
And it's almost impossible to debug after the fact.
Nasty. Okay, next up, since we're building this synthetic workforce with APIs, we have token or credential compromise.
Think of it like identity theft for your digital workers. Your AI systems use API keys and access tokens to prove who they are. If an attacker steals one of those keys,
They can impersonate one of our legitimate agents.
and they get all the same authority.
Yeah.
They can act as a rogue insider participating in your workflows, accessing your data.
And finally, number 5, which really speaks to the nervous system we talked about a few deep dives ago, agent-to-agent attacks.
This is for when you have a system of multiple autonomous agents working together. If one agent gets compromised, say your research agent, it can start feeding false data and bad instructions to all the other agents in the system.
So your entire synthetic workforce essentially turns on itself.
It starts operating on intentionally false premises. It's a system-wide infection.
That list makes it crystal clear why legacy security just won't work. We need a new structure.
So let's get into the 7-step governance framework. What's the very first operational step?
Step 1 is detection through visibility. You absolutely have to know what AI services are being used on your network, period.
And how do you do that?
This means deploying specialized tools, specifically Cloud Access Security Brokers, or CASBs.
For listeners who aren't familiar, what's a CASB and why is it different from a normal firewall?
A traditional firewall just looks at traffic at your perimeter. A CASB is designed to monitor and manage access to cloud services, like all the big public LLMs, even when your employees are outside the main network. It's how you spot that unauthorized browser tab in real time.
Okay, so once you have that data, what's step 2?
Behavioral recognition. Policy alone isn't enough. You need anomaly detection to find risk patterns that a policy might miss.
Like what?
Like unusual data volumes being sent to an AI tool or an agent accessing a service it never has before. You're looking for the pattern of risk, not just the use of a specific tool. Then we're back to the trust paradox with step 3, structured permission. This is making that registration process 3 hours, not 3 weeks.
Precisely. A fast, automated workflow. Make compliance the path of least resistance.
Step 4 gives us the structure to track all this, the AI registry.
And this has to be a living inventory of every AI tool, model, and agent. But the crucial part is accountability. Every single entry needs a designated steward.
The human owner.
An owner. Someone accountable for its output, someone who updates it, and this is critical, someone who is the designated killer if the system goes rogue. Without that, the system is fundamentally unsafe.
Right. Then step 5 is for managing experimentation. AI
You
sandboxes.
have to give people a safe place to play, a contained environment with guardrails, limited or synthetic data, and monitored outputs. It channels that shadow AI energy into a governable space.
And step 6 is about creating the audit trail, centralized gateways.
Every single AI interaction, every prompt, every output gets routed through a central gateway. This gives you a traceable history for when things go wrong, and it's your enforcement point for filtering prompts and blocking sensitive data.
And finally, step 7, to match the control to the risk. Tiered acceptable use.
You need a building code, not a ban. You define tiers. Public LLMs might be okay for low-risk brainstorming, enterprise platforms for sensitive production work, and then a clear list of prohibited tools. The control always has to match the risk level.
That framework provides the structure. But there's one more piece, a safety net. The kill switch protocol. The book says if you don't have a kill switch, you don't have a workforce, you have a liability waiting to happen.
It's absolutely non-negotiable. For every single AI system you deploy, an emergency shutoff, and it has to be fast measured in seconds, not minutes.
Wait, seconds? How is that even possible in a complex system with overlapping processes? What kind of trade-offs do you have to make for that?
It means you can't retrofit it. You have to design for it from the start. You have to define what triggers it, specific error rates, anomalous behavior. You need multiple people with authority to pull the plug, so there's no single point of failure.
And you need a fallback plan.
You need to know what process takes over for the work that was in flight, and you need a communication protocol ready to go. It's not a button. It's a critical piece of operational design.
And all of this whole governance investment, it has to connect back to the economics.
Right.
This isn't just a cost center. There's a real ROI.
A massive and quantifiable one. The data shows that organizations with these AI-specific security controls reduce their breach costs by an average of $2.1 million compared to those who didn't.
$2.1 million, that alone justifies the entire framework right there.
It does. And beyond that, it's about operational speed. These same organizations report incident response times that are 40% faster.
And fewer false alarms.
60% fewer false positives. You spend less time chasing ghosts and more time on real threats. It directly improves your efficiency and lowers your risk.
It's a compelling case for making governance a priority from day one, not an afterthought.
So to wrap up the principles, shadow AI surfaces in trust, so you have to provide that frictionless, sanctioned path. The 5 threats we talked about demand AI-specific controls. And that kill switch protocol. It's your non-negotiable insurance policy.
So we've built the foundation, hired the synthetic workforce, set up the infrastructure, figured out the economics, and now we've locked down the control structure.
The whole thing.
Which brings us to our final deep dive in the series. Chapter 10, The Architect's Playbook. This is where we bring it all together. The balance sheet, the agents, the nervous system, the ROE, the governance, into one complete blueprint for actually designing and scaling this.
The final, complete map.
But before we get there, here's the question you need to be asking yourself regularly for any system you deploy. It's a critical safety question. What is the blast radius if this AI is wrong? We'll see you next time on The Deep Dive.